Okay, so we are given a circle, unit circle, and we're starting at the point 1, 0, and we're traveling around this circle a distance of t, and we're going to end up at a point probably right about in here, where the x coordinate is 5/13. That's a little bit less than a half. And the y coordinate is 12/13. So that's almost 1. So that looks like about the appropriate spot here in my drawing. I traveled the distance t around the circle. And some of the questions that we're looking at is, well, if you continue along an additional distance of pi units, where will you end up if you continue, if you look at like t plus pi, if I add pi to that, where will you end up? But one of the nice things to think about is to remember that we're working in the unit circle, so a circle of radius 1, and we know that we have that formula relating arc length and the angle, that s equals r theta, and since r is equal to 1, we know that the arc length is equal to the angle. So one way to think about it is that t is also the measurement in radians of that angle there, made from the origin out to our point 5, 13, 12/13. And so if you travel an additional distance of pi or through an additional angle of pi radians, what are the coordinates of where you're going to end up? Or if you were to go 2 pi, where would you end up? Or what about minus t? Where are you going to go if you go minus t? So instead of going counterclockwise, maybe you go clockwise, a distance of minus p. What are the coordinates of the points that you're going to end up there? I think if you think about it and look at the geometry of the situation, I'm pretty sure you can come up with that answer. But a sketch, I think, is the key. A good sketch is the key to um, coming up with a solution there.